Okay, hello. So, what are the good practices of requirement specification? That's the topic of this particular video. Good practices, I think by now you're already kind of familiar with this idea of good practices, okay? Best practices are like rarely effective in our domain, in real life. We just have good practices that we believe that they are like applicable in majority of the situations that you will come across in real life. First, I'll be talking about 5 of them. The first one is adopting a requirements document template. We're talking about specifying requirements, we're talking about coming up with a document, or not necessarily a document, by the way. Please take a look at the handout, and you will also see other types of kind of way what we understand by when we say document. So it may as well be a kind of a repository or database that you store your requirement statements. But anyway, fine, adopt the requirements document template or a requirements specification template, because there's no need to reinvent the wheel. Okay, we'll talk about that. Uniquely label each requirement so that we understand when we say, hey, which requirement XYZ. Don't leave it like open. Record business rules because they're important and they influence a lot of other type of requirements. Identify requirements origins, like established traceability. We'll spend more time on that. And finally, specify. Don't, let's say, forget to specify non-functional requirements, including the quality requirements that we have covered in another video module. Okay, now let's start with the first one, adopting a requirements document template. Again, why? Because it's just like it's a kind of a helpful reminder for what we need to include in a requirement specification document or in a repository. Okay, and the course book itself, one of the course books, let's say, from Uyghurs, already offers quite nice templates that I have already kind of asked you to use in an assignment A and assignment C, the vision and scope document assignment A, and software requirement specification in C, and in fact you may as well use the use case document in assignment C. But there are other ones, in fact commonly used in practice as well, like the Bulgaria template or the very old traditional IEEE software requirement specification template. It's a kind of a very old one and like hundred thousands of times used in practice by now, but I think it's rather outdated. The one that's proposed by Uyghurs right now is much better, in my opinion. Good options for specifying requirements. So something that I would like to talk about as well when we talk about specifications. So there are different type of options that you can use to kind of specify requirements. Okay, and one way is to use natural language, which we call it informal. Okay, so it is well structured, it is carefully written. I mean, you can come up with something that is carefully structured, carefully written in natural language, and the advantage is, of course, that, I mean, if your audience know that language properly, then it's an advantage, or it's it's a good thing that everybody can understand. But the disadvantage of using that is that natural language is known to kind of known to be open for different interpretations, and known to inherently kind of have some sort of an ambiguity in it. Okay, and nobody wants to just read like hundreds of pages anyway, so it's not exact, it's not precise at all. Semi-formal ways are like using visual models, system states, use case diagrams, and activity diagrams, and so on, flows. That's a good option anyway. I mean, you know, the advantage is that the picture is worth 1,000 words, so it's much better. But sometimes it's not known by or may not be known by your audience. For instance, if you use BPMN2 diagrams and the advanced versions of BPMN2 diagrams, it might be a little bit difficult for your audience to follow and to understand and to really properly give you a feedback. Formal. There are also formal ways, like mathematically precise ways to specify requirements, and one of the examples is like the Z language, There's a link that please check that one. The advantage is obviously exact, precise, formal verifications is possible. Like you can really, like you have to be very precise. You're talking about mathematical formulations, and that might be quite suitable though, even sometimes necessary for like mission critical systems like aircraft, air traffic control system, or nuclear power plant control system. But of course the difficulty is, first of all, it takes quite a lot of time to specify, formally specify using that language, and it's not a common skill at all. Okay, so it's a very specific thing. Now, a good practice is to use something in between, like semi-formal, I would say, using structured natural language. Structured mean, we'll talk about structured anyway, so it's not like in a kind of a literature thing. It's like you have to be very precise in using your natural language, plus you have to use visual representations, models, and so on, and some other representations as well, like tables. Fine. That is, in practice, the one that works best as far as our experience goes. Okay. Software requirements specification document, also known as the functional specification, product specification, system specification, or requirements document. It specifies, I mean, we're still talking about templates, okay? It simply specifies the functions and capabilities that an IT system or software system must provide, its characteristics, the constraints that it must respect, and so on. Should not contain kind of information about the design, construction, testing, project management details, and so on and so forth. It has to be about the requirements, and that's it. Of course, other than the constraints that are related to implementation and design. So it might be that you impose some design constraints or implementation constraints that we'll be talking about, but that's not like, that's coming from the users, okay? As long as, so you don't go into the, let's say, into discussion of internal structure of the system and components, and that is a design concern, and you shouldn't just specify those type of things in the requirement specification documents. You have to be in the user, or let's say requirement specification domain. Good. Template that in fact you also follow for your assignment C: introduction, overall description of the software, system features. You can just have different type of ways to structure this particular part. Data requirements, logical data model or the data dictionary, or you can also have ER or class diagrams here. External interface requirements as part of non-functional requirements, user, software, hardware, and communication interfaces, quality attributes, devoted a separate module for that, international and localization requirements, and other type of requirements, glossary and analysis models and use case models, if you like, or any type of an appendices that would help the audience of the targeted audience of this particular document to understand you better. Fine, that's the template you'll be following, or you have started already following for assignment C. Also, take a look at, I mean, this is a special note, take a look at the use cases. In assignment C template, there is a special section about how you can incorporate use case definitions into an SRR. There are different options, you have to pick one. Okay, let's go back to this 5 good practices of requirement specification, adopting requirement specification template. Now the second one is uniquely label each requirement. Every requirement needs to be uniquely or needs a unique and persistent identifier, okay? So that we can refer to that specification in any kind of a discussion, or let's say, so that we can in fact establish traceability that we'll discuss later on. Some good practices in labeling is that you can, like you can have this hierarchical numbering, okay? Here you see this kind of like the labeling structure, requirement type, specific function, and plus hierarchical numbering. functional FE1 performance requirement 1.2 and so on and so forth. Or another one, text-based hierarchical tagging with an optional hierarchical numbering. This is the one that I think the Uyghur's template has followed. You will see examples of this way of uniquely labeling your requirements in the example document that we posted for assignment C. Okay, so like print, confirm, copies. So it's a little bit more, of course, informative, but at the same time it has a cons as well. The disadvantage is that it's rather long. And if you have a huge, like a tree of hierarchy, then of course it becomes really huge, like stack of words coming all sequentially stuck together, which is of course not nice. Okay, 5 good practice of requirement specification. I skipped the third one. Take a look at it in the handouts. Identifying requirements origins, which means in fact establishing traceability. It is important. It would be, or let's say under certain conditions, it might be important to trace each requirement back to these origins to understand why a requirement was needed in the first place, and also to analyze what the impact of change would be later on. Traceability among which? Among what aspects? Traceability, you can establish traceability of a requirement statement with the use cases. Now you can say, okay, this requirement statement refers to this use case for a customer input, elicitation note, high-level system requirement specification, contract of business, a business rule, for instance, laws, regulations, and standard, the rules that are specified in those kind of requirements or directives. So that's about traceability, and we'll see more about the traceability later on. So that is kind of, there's this fifth one which we'll spend more time, this fifth good practices which we'll spend more time on that later on. Okay, that is it for this particular module, and yeah, we'll be seeing each other later on as well in other modules.